Hello, everyone. Dr. White back again. We're at the beginning now of Open Intro Statistics, Chapter 2, Section 2, Considering Categorical Data. So we'll have a couple of screencasts on this topic. Now that we're at the beginning of a new section, here I am looking at RStudio. I think I might talk to you about what you should think about when you move from topic to topic in terms of RStudio and just how to look at it and manage it to keep yourself from being confused about things. So I'm looking at RStudio now and I notice I've got some things over here in the editor pane that were from the last section, and I don't think I'm going to need them right away, maybe never again. So why don't I close them out? Right now the DA is up on top. I'll just close that out. Remember, it's still back in my submit folder. It hasn't been lost. Now the view of fuel is up. I can just click that away. If I ever need to view it again, I can just run the command view fuel in the console. Same for geyser and email 50. Alrighty. Looking over in my global environment, I see there's a couple of objects that I created in the last section, and I probably don't need those around either. So I'm going to push the little broom and say, yes, I want to clear out my global environment. And I look over here in the files, and I see that I'm looking in my home directory, which is a great place to start. So just consider resetting yourself like that every so often. If you really, really want to reset, you could go to Session, and then you could say Restart R. And that'll start off your R session right from scratch without any of those packages attached. And then you're really starting from scratch. I'm going to do that this time. I don't think you really have to ever do such a thing, but if you do, then just make sure that you keep track and attach packages as you need them. Okay, so section 2.2. Why don't we grab the slides and start working through them a little bit. So over in Files, go to the // /com for the common folder. Okay. Dr. White stuff. And inside of Dr. White stuff, map 111. Inside of that, slides. And inside of that, OS-2.2 Categorical Data Slides HTML, push to blue text, view in web browser. Up they come on a separate tab in whatever browser you're using to get to RStudio. All right, let's begin. Categorical data. So that refers to variables in a data set that are not numerical. Their values aren't numbers. Instead, they stand for different groups of the individuals in your data set. Packages we're going to need today. The TigerStats package and also the Open Intro package that has lots of data sets that are specific to this course. We're going to need to get both of them attached to our R session. So I'm going to copy, Controller Command V, go to RStudio, head down to the console, make sure my little flashing vertical sign is next to the blue prompt where I'm waving my mouse down at the bottom. Controller Command V to paste. Whoops, and that apparently did not manage to copy because I pasted some old text from my clipboard. Never mind, I'm just backspacing and heading back to the slides, and we're going to try this again. Copy. Paste, there we go, and run. And since these packages really are being loaded, I get talked to a lot about everything that's happening. It's sometimes worth it to read some of these messages. A lot of them are technical, but there's a little one down here that actually gives you a website you can go to learn more about the TigerStats package. You'll see this every so often when you load packages, and it's not a bad thing to be done. Okay, what's up next? So first, we want to talk about how you would describe patterns that you see in when you're studying data regarding one categorical variable. So let's learn about a new data set. The name of the data set is email. It's from the Open Intro package. So you can view it and get help on it now that Open Intro has been attached. So we'll go ahead and do this here. Whoops, wrong RStudio. Here we go. All right. So according to the help, this data represents incoming emails for the first 3 months of the year 2012 for some email account, which is described here down in the source of the data, way down at the bottom, I would think. Yeah, there we go. All righty. And every line, every row in the data set is an email. And then there's a bunch of columns that represent variables that were measured on each of the emails. So this is very similar to a data set we've already looked at called email 50, which was actually just 50 rows randomly selected from this data set here. So a couple of variables of interest. Spam. And so that's a variable that's actually represented with numbers 0 and 1, but they're really just codes for two different groups. 0 stands for this email is not spam, and 1 stands for this email is spam. And as you can see, most of the emails are not spams, but if you scroll down far enough, you'll see some 1s there. And plenty of other variables here. But I'm only interested currently in number. And when I look in the help for number, it says this is a factor variable. That's just another word for categorical variable. Factor variable saying whether there was no number, a small number, or a big number mentioned in the email is what they mean. So if the email text didn't have any numbers or references to numbers in it, then there would be I think the word no or none. Yeah, none. And if the biggest number that was mentioned was a small number, like under 1 million, then it would say small. And if it mentioned a number that was over 1 million, then we say big. So this is a categorical variable with 3 values. I would say it's an ordinal categorical variable because they come in an order: none, small, big. Okay, and they serve to divide the emails up into those 3 groups. So those are the 2 variables I'm going to be interested in with regard to this data set. And for now, let's just focus on the variable number, one categorical variable. How do you study the distribution of a categorical variable? Well, you can use the R function tally. And what you do is inside the parentheses, your first input says what variable you want to study, and it's number. And to specify that it is a variable, you give this little twiddles at the beginning that cues R to say, oh, this is a formula that tells me what variables are under consideration. And the next input after that comma there is the data set where the variable lives inside. So that's the email data set. And then a comma. And then margins equal true is going to give you a margin for the little tally table that is printed up. And if you were to, like copy paste and run this in RStudio, which I recommend you take a second to do, and then come back and start this video again, you'll see this output here, okay? And the margin is this column total here with the number along with it. So that there's the 3,921 total emails, and we find that 549 of them were small, but 549 of them were in the group none. They didn't mention a number. The vast majority of them mentioned a small number, and some of them also mentioned a big number. 545 of them mentioned a number over a million. And so that gives you some idea of the distribution in terms of like what groups were common and what were not. But really, to show the distribution of the variable more precisely, it's a better idea to compute percentages, okay, of the different values of the categorical variable. You can do this with the exact same code, except add another input down here at the bottom, format equals quotes %. And the result is going to be a tally table with percentages instead of the raw numbers. And so what we're finding is that 549 emails that did not mention a number, they constituted 14% of all the emails. 72% of all the emails mentioned a small number, and 13.8% mentioned a big number. The two tables with the raw numbers and the percentages work really well together. It's nice to know the percentages, but it's also nice to know like how much data that percentage was based on. And that's where you go back to the raw numbers. Now, you can also show a distribution of a categorical variable using a graph. Probably the most recommended way would be with what we call a bar plot. And so you see one here. Along the x-axis are the values of the categorical variable number: none, small, big. And on the y-axis, which is called count, the height of each bar says how many emails were in each group. And so this height here must be 549, and this height here must be the 2,827. And 545, I think it was, for the number of emails that mentioned that big number. And so that's a visual way of seeing that the vast majority of emails mentioned only a small number. So how do you get that bar plot? Well, again, GF underscore the type of thing you want to produce. So a bar plot this time, GF bar. And of course, always parentheses when you want to actually use the function. And then your input separated by commas. And it's just so similar to tally. You just say what variable you want to study with the twiddles in front, data set where it lives, and then a couple of options that are specific to bar plots that don't pertain to tally tables. What color is going to be inside the little bars? What color is going to be on the boundary of the little bars? This one's a good one, I think, to just make sure we stop, copy into RStudio, and paste in and give it a little try. And let's zoom this up big for a moment. Yep, we're sure enough getting the bar plot that we asked for. And it's always good when you're doing this to just experiment a little bit. So, for example, you might ask yourself, would this work? Like, could you make a bar plot that shows like how many are spam versus are not spam? That's a number variable, like it's coded as a number variable. even though it's categorical. I wonder if that could work. So let's go to the console and up arrow and get the previous command. And let's just put spam right here. And let's just see if we can get a little bar plot of whether or not it's spam. I'm going to zoom that up. Yeah, it looks like it worked. And so there's a bar over 0 and a bar over 1. And the bar over 0 has got way more height than the bar over 1. The vast majority of emails were not spam. So that worked. That kind of experimentation, the more you do it, the more comfortable you get with the R code that underlies this course. Okay. How would you study the relationship between two categorical variables? Let's move back to another data set we've already looked at, the M111 survey data set from the TigerStats package. So let's do a quick view and help on it. So head back to our studio, copy in the view and the help, and we'll just look at the view right now. Remember, every row was a student that was in this survey that was given to all Math 111 students one semester some years back. And I'm just going to pick out a couple of categorical variables that I'd like to study together. First of all, sex here. When people took the survey, they only gave 2 responses for their sex, female and male. There wasn't any other response people gave. So categorical variable, categorical ordinal, categorical nominal. And then seat, okay? And so when you look in the help, you see seat. It was a response to this question: when you have a choice, where do you prefer to sit in a classroom? And these are Georgetown College students, and there tend to be, like, when they're in the classroom, there might be 4 rows of chairs if they're in rows. And the first row would be kind of considered the front to most people. The second and third row would be the middle, and the fourth row would be considered the back. And that's pretty much how people were thinking of the question. And the responses are entered here as 1_ front, 2_ middle, and 3_ back. That's an ordinal categorical variable. So those are the ones we're going to be interested in. And I'm wondering, is the variable sex associated with the variable seat? Does sex have anything to do with seating preference? Or another way of asking it is, do the 2 sexes differ in where they prefer to sit in a classroom? So that's our little research question for a minute. How are we going to go about answering it for ourselves? Well, we think about the variables that are involved, sex and seat, both categorical variables. And it's really good to see, first of all, if we think of one of the variables as the explanatory variable. And I think we do this time. I think that sex would be considered an explanatory variable and seat would be considered a response because, oops, I don't know what that's doing. Because, your sex, kind of once you've got it, you grow up and you kind of get culturally conditioned in different ways, according to your sex. And could it be that males are sort of culturally conditioned different from females to prefer, different seats in a class? Who knows? So I don't think it's the other way around, though. Like, I don't think if you changed where you prefer to sit in a class, that would change your sex or anything like that. So we'll go with this way of thinking about it. Sex is the explanatory, seat the response. Okay, now that's going to help you to figure out how to study the relationship between these 2 categorical variables. You're still going to use tally even though there's 2 variables involved. But you get those 2 variables involved right up front in the little formula. It's response variable seat, twiddles, and then explanatory variable sex. That's the way to go. and then the data set where they live, and the margins equal true. I almost always like to use that. And here's what you would get if you ran this code in the RStudio server. You would get, there were 40 females. Out of the 71 people in the survey, 40 were females. And 19 of them preferred the front. There were 31 males. 8 of them preferred the front. So, that's how you read this table to yourself. And of course, it's natural to start comparing things, like compare the 19 to 8. And gee, 19 is bigger than 8. Does that mean that more females tend to prefer the front more? Well, you have to kind of stop there and say, wait a minute, there's more females than males in the study. There's 40 versus 31 females. So you just by that alone, you would kind of expect to see like a bigger number here than over here. So is the 19 really that much bigger than the 8? You need to correct for the difference in these group sizes before you start drawing any conclusions. So what you do is you get column percentages. And if you take the same inputs to tally as before, but you throw in format equal %, then those margins you have down at the bottom that gave the totals now become total percents, and all of the entries become column percentages. So just to show, copy, head to RStudio, paste, and sure enough, there's that table. And so the way you'd read it is that, like this number here, 47.5, you would say, out of all the females, 47% of them preferred the front. So that 19 out of 40 was actually a 47.5% all along. 19 was 47.5% of 40. And in the same way, 8 out of the 31 males preferred the front, and that was 25.8%. And similarly, 40% of the females preferred the middle, 51% of the males preferred the middle, 12.5% of the females preferred the back, and 22.58% of the males preferred the back. Okay. The column percentages are really your key to describing patterns you see in this data, relationships between the two categorical variables. So here's how I suggest that you go about describing these relationships. What you do is you look for rows where there's a big difference going across. Sorry, you look for rows where there's a big difference going across. A big difference in the column percentages going across the rows. For example, that difference right there, 47.5% versus 25.8%. Seems like a big difference. And you state that difference in words, but using the numbers to back up your contention. So you, based on that row, you could say this. Women were more likely to prefer the front than men were. Sorry for the misspellings there, from and mean. Front and men is what I meant. And then in parentheses, I cite the numbers that told me that. 45% of women preferred the front versus only 25.8% of the men. Okay. Any row where there's a really big difference is worth focusing on, and you could describe the relationship that way. So like you could also focus on this row, the 12.5 versus 22.5. That's striking because 22.5% is like nearly twice 12.5%. So you could say something like this. Move this out of the way. Men were nearly twice as likely to prefer the back as women were, 22.5% versus 12.5%. So either way is fine. Putting both together is also fine. It's not so super useful to focus on this row where the difference is not so big. Instead, I'd focus on either this row where the difference in percentages is big, or this row where the ratio in percentages is really striking. All righty. So my pro tip for making these two-way tally tables, these two row, two column, these row and column tables are called two-way tables. They're also called contingency tables. You'll see both that terminology. The way to make it in R here is to tally your response variable twiddles your explanatory variable. Okay? That you're going to find it much easier to describe any relationship you see in words. And it's really super important that when you make column percentages, then to describe a relationship, you've got to look for differences in column percentages across a row. Okay? If there are big differences across at least one row, the two variables are related, and you can go ahead and describe specifically the nature of that relationship. But if there's no row with big differences, then you just got to say the two variables don't look like they're related. Never compare column percents down a column, okay? That's not going to tell you anything. And we'll see why in just a moment. I want to give you an example of a situation where there's really no relationship between the two categorical variables in the data. So I'm just got some hypothetical data up here. You could imagine it's data where every row is a person and you've recorded their eye color classified as either dark or light. Okay. And you've also recorded like what their major is. Is it a major in the humanities, like English or philosophy? Or is it a major in social science, like psychology or sociology? Or is it a major in natural sciences or math, like mathematics or chemistry or something? And let's say that there were 400 people who had dark eyes and 200 people who had light eyes. And here are the breakdowns in their majors choices. Now, of course, you can't just compare the raw numbers because the dark group is bigger than the light group anyway. So you had to make some column percents, and then you look at it. And you compare the column percents across the row. 30.25 versus 33%. Not a big difference. 49.25% versus 47%. Doesn't feel like a big difference to me either. 20.5% versus 20%. Not a big difference. No significant differences between the column percentages across rows, and so you would say these two variables don't look like they're related. So it's going to be a bit of a judgment call when you're deciding whether a difference is, big or not big, and whether that makes it into a significant or important difference. And strictly speaking, you've got to learn some more inferential statistics, like later on in the course, before you can make more clear judgments about that. So don't worry, don't stress. Just kind of use your intuition at this level, and you'll be okay. That's a small, insignificant difference. But also I want to point out how useless it is to compare column percents down a column. Let's try it out. Like, hey, for the dark-eyed people, like almost 50% preferred social science. That's a lot more than preferred like math and natural science. That tells you nothing about the relationship between the two variables. Because look over here. The same was true for people with light-colored eyes, So comparing column percents down a column is not going to tell you a thing about the relationship between the two variables. You could have a big difference like this versus this, and yet the two variables are not related to each other. The eye color and the major are not related. If you've got dark eyes, your chance of being a humanities major is just about the same as if you had light eyes. And same for the other possibilities. Eye color just didn't seem to have anything to do with choice of major. I should point out that you can use bar plots to show the relationship graphically. So here's a bar plot of the seating preferences, but broken down by the sex of the respondent. And they tend to be a little harder to use and to interpret than those two-way tables that were produced by Tally. I mean, you could do it, but it's tough. So, for example, you could notice that the males here are turquoise. You can notice that, like, it looks like kind of like this bar here is like almost as much as these two bars put together. So about half the males are in the middle. Whereas with females, like, this bar is like really big compared to, this bar, and especially this bar. Females seem to be more like front and middle type people, and they don't seem to like the back. And so you're having to kind of jump horizontally across, and for each sex. And so it can be a little bit hard to use a bar plot to talk about these relationships. But if you want to learn how to make them, they are cool to look at sometimes. Here's how you do it. GF_bar, okay? So same as bar plots for one categorical variable, GF_bar. Now, in the formula part, you don't put both variables. You just put twiddles the response variable, okay, that you see. And then where the variable lives, color is going to be the boundary on the bars. Fill is the color that's inside the bars. And if you set it to twiddles, the explanatory variable, it's saying choose a different color for males versus females. Position equals dodge means that when you do the bar plot, that the bars for the two sexes are set right next to each other instead of on top of each other. They like dodge each other. And the X label is shown here. Oops, this little seating preference, that's the X label. So this is worth maybe copy pasting and experimenting with a little bit. So head to RStudio, paste it in, wait for the plot, zoom it up, see if we got it. Yep, that's our plot. And like, what would happen if we left out position equals dodge? So I'm just going to up arrow here next to the console, getting the command back. And I'm just going to erase position equals dodge and then run the code again. And you get a totally fine bar plot. It's just that the bars don't dodge each other. They're all exactly over each individual group, front, middle, and back. So that's totally fine as well. Let's do another example. Let's head back to that email data. And in addition to the number variable that we've looked at, there was that spam variable where 0 was code for that the email was a legit email and 1 was code for it's a spam email. And I got a little research question for us here. Would knowing what size number an email mentions help you to judge or predict whether the email is legitimate or spam? Could you use number to predict spam or not? Well, let's see. Let's think about it. In the variables involved, I would say number is the explanatory variable this time because we're trying to use number to predict whether or not it's spam. Spam's the response, and so when you make a tally table, you go tally response variable twiddles explanatory. And you get this table down here. And since the groups here are very different in size, most of the emails mentioned a small number, you're totally going to need to use the column percents to try to describe the relationship. So try tally, same stuff, but format equals percent tacked on. And then you can start to look at describing the relationship by comparing the column percents across a row. And so here's one way to address the question. This way focuses on this row. An email that mentions no numbers is much more likely to be spam. 27% chance versus a 6% chance for an email mentioning a small number and 9% chance for an email mentioning a large number. Yeah, check it out. 27 versus 5.9 and 9.17 is a big number compared to those other two. If you don't mention a number, you have more than a 1 in 4 chance of being spam, 27% chance. Whereas if you mention like a small number or a big number, your chance of being spam is much less. So that's a great way to describe the relationship. You could also build up a description using the first row because there's some big differences across the first row. And again, bar plots can show the relationship. How did we make this bar plot? Here we go. So twiddles the response variable, the data where the variable lives, boundary color, the fill. Now this is interesting. It hasn't been set to twiddles spam. It was set to twiddles factor spam. And then the position equals dodge like before and an X label like before. So the fill parameter here is helping us to color the bars by the group of the, given by the explanatory variable. But what's this factor thing? It was needed in order to turn the number variable spam into a categorical variable for real. Really is a categorical variable, but was getting coded by numbers. And R sees it as numbers until you tell R to stop seeing it that way. And the factor command does that for you. Now, this is not usually going to happen to you. And so, don't stress. It's not going to happen to you in some test situation, where you just have to, miraculously remember this little thing. These are the kinds of things that you learn gradually over the years as you work more with whatever programming language underlies your statistics work. So, but it's also just as useful to kind of get it into your head by experimenting. What if you didn't do factor? Let's give this a try. Copy. Paste, run. Zoom it up. Yep, there it is. Okay. And let's get back to the console and up arrow. And for the fill, let's just say it's twiddled spam instead of twiddled factor of spam. And run this. And pop it up. And it's just a total disappointment. It just looks like it was making a bar plot for the single categorical variable number, which was small, none, small, and big. It just totally ignored breaking down into the two groups of the explanatory variable. So that's the result of R being confused. For making bar plots, it's expecting to be looking at categorical variables and not things that are coded to it as numbers. So that's enough for this screencast. When we get together for the next screencast, we're going to look at how to study the relationship between a numerical variable and a categorical variable in a data set. And this is the topic that's called in the book, Comparing Numerical Data Across Groups. See you soon.